All right, so the recording has started. Good afternoon, everybody. Welcome to Code Talk Sunday edition. We're going to be looking at Git history. Who has ever tried to undo a change in Git before? Ian?
Yes.
And did it go well, or did you have some complications? A little bit, okay.
Only with checkout. And I don't remember, it depends on where that file is.
Mm-hmm.
The whole, like, has it actually been staged or something? So that's the only time I've ever been able to do that.
Okay.
But not to undo, like to go back to a different point.
Got it, right.
It's always been like a real pain in the ass whenever I've done it. I always have to like Google stuff and it's annoying.
Right. So hopefully we can make it a little easier. At the very least, maybe you can know how to get to the right Google result faster. Even if you don't memorize everything we covered today, at least you can maybe hopefully get to where you want to get to in less time with less of a headache. All right. Can everybody see my screen?
Yeah.
Mm-hmm.
All right. I am using, so the reason this is black is I have a little add-on. So if that does end up bothering anybody, I can change that.
Okay.
So the main concept that we're going to cover today is we're going to look at what Git actually is, what it does, and there are three main areas that Git actually keeps track of or knows about. And we're going to look at how commits, branches, and the head relate to each other and what those things really are. And we're going to talk about good Git practices. And these are all really important if you want to work with Git history. Let me move this over here so I can look at the right screen. No, you can't see the screen now, can you, if I do that? Here.
Was that you?
Let me move my camera.
Was that you?
Was what?
Or was that you climbing that mountain?
No, I've never climbed a mountain.
I was going to say that's pretty impressive, but okay.
Yeah, I don't know who that. I am not impressive. Don't give me that status. I don't know. I have random backgrounds on my Windows 10 computer, so that's just one of them apparently. All right, so these are all really important if you want to work with your history, because if you don't understand these things, then you're going to be playing a guessing game the whole time. So I hope we have enough time to go through these things in the detail that we need. And if anybody gets stuck at any point, just stop me, and I'll be sure to try to answer some questions. These are the main commands that we're going to cover today in relation to these concepts. And if you've never seen these, or if you're not familiar with them, we'll do some demonstrations together. And I hope we can get through this in a way that's meaningful to everybody today. All right. So I do have some cool resources, and I do have a little outline that I can share with everybody too afterwards, if anybody wants to see that. So when we talk about the three Git areas, we have a working directory, the stage or the index, as I've learned it's called now, and we have the repository. So the working directory is going to be our files on our computer, right? These are the things that you actually create when you create a new file or a new folder. The stage is where we prepare our changes to be committed, and the repository is actually our branches and our commits. And I found a really, really cool, if you guys don't ever use the gitscm.com website, I cannot recommend it enough. It is really, really good. So this was really helpful, this whole thing. So here, we're just going to skip past a lot of this, and we're going to look at this right here. So this shows us the working directory, the index, and the head. So this is, again, your local computer files. This is the index where they're prepared to be committed. And this is the head, which is really the same thing as the repository here. We can we'll demystify that later. And we're pretty familiar with this. When we stage a file, we move it from a working directory to the index, right? And that we use that with git add. That prepares it for the index. And then we run git commit, it pushes it into the head or saves it into the head. And likewise, if we check out a branch or a change, it brings those changes into our working directory. So this has a really good visualization. We're going to kind of scroll through this quickly. So, and I'm just going to sum up all these words they have here. So here we've created a file. It's our working directory. Our index doesn't know anything about it, and our head doesn't know anything about it. So when you run the git add command, it now is copied over into our index or to our stage. So now our working directory and our index are exactly the same. And now if you run git commit, it saves it into the head as a snapshot. So now all three areas are exactly the same. And if you run a git status, it'll say working tree clean. Whereas before, if you run git status here, it'll say that the stage has files that are ready to be committed, right? And if you run git status here, it'll say that there are untracked files that you can add. Git status is a really, really useful command, and we'll do some of this together as well. Now they've changed a file, right? So now it's updated. So now if you run git status, you would see that there are changes not being tracked. So now they've added them. So the index and the working directory are the same. And here they've committed those changes to where all three are the same again. What's on your local computer, what's in the index, and what's actually in the repository. And we will look at some of the resets and things more later. But is this basic, does this make sense? These three areas that Git works with?
Could you clarify something?
Yeah.
Would index be the same as the staging area?
Right.
Is that's what you said? Index is the same as stage?
That's right.
Okay. Thanks.
When I first learned this, I learned it as the stage. And when you run git status, it'll even uses the word stage or unstaged. But now the term is the index. And the index is actually a file, and it is the right term. And there are some cool things you can do with the index that we're not going to look at today. So it's important to know that phrase for if you need to Google git index or git stage, it'll work.
Hey, Guy.
Yeah.
Sim is asking, where does git push come in?
I need to bring up the comments. Thank you.
I can be your chat monitor too if you want.
Yeah, that'll be helpful.
TA.
Chat. All right. So git push then would be a fourth box or a fourth area, which would be working with remotes. And let's bring up, I have another cool little visualization, a cool website that we can look at. So this is from a guy named Oliver Steele. I don't know anything about it, but I saw this little diagram and I thought it was really cool. So, and let me just make this white. It makes it easier, some of these things. So here's our workspace, our local, the index, the local repository, and remote repository. And he shows all the different commands to move files and work with files from each to another one, right? So then push goes from your repository to the remote. Pull brings them from the remote into your workspace. So that's just a fourth area, and this adds another level of complexity that we're not going to deal with too much today.
What are the parameters that he had listed there? He had commit-A, add-U.
Right. So I'm not familiar with the U, but commit-A will add.
The U is to track that like, I'll look it up real quick, but I'm pretty sure that means like, hey, we're adding this, keep track of all the changes we make to this from now on.
Isn't that what but git add does that too, right? Or is it just a substitute for git add?
If we have some time at the end, we'll look at this together.
Okay.
But yeah, I'm not sure what the U is. I know that commit A does the add and the commit step all at one time. So if you have unstaged files, you can just do commit A and it will stage and commit it at the same time.
It would stage all the unstaged files.
It'll stage whatever you tell it to stage, right? So if you did add period, it adds everything, right? So if you did commit minus A period, it would stage and commit everything.
Okay.
That's right. So it just means add. We're going to add and commit in one step, which is why he shows we're going from the workspace, we're going to bypass the index and go directly to our local repository. That's what this does.
Okay.
Yeah.
But what's the difference, I see here that there's a difference between git fetch and git pull.
Yes, right.
So git fetch just syncs the remote with the local, but it does not touch your workspace or index.
That's right. It doesn't change your local files. So if your files are different from the remote and you pull, so pull is 2 commands in one. It is fetch and merge. So when you pull, it'll fetch the files and then merge them into your local workspace.
Okay.
If you just fetch, it's not going to make any changes in your workspace yet, and you can decide to merge those or discard them at that point.
You have to do an explicit command git merge at that point, or do you just?
We would merge if you wanted to merge the files, or you can just fetch and look at them without actually making any changes if you don't want to.
Okay.
Right. Okay. So those are the 3 major areas that we're going to be looking at today: is the working directory, the stage or index, and the repository. And let's go ahead and maybe move into showing a little bit of that. I'm going to actually go into a little project that I have that I'm working on. Forget. I should have had this up already. That probably would have been helpful. That's right. So I need to do, I need to figure out how to work with Ruby spreadsheets or spreadsheets in Ruby. So that's what I'm working on here. So you can see I'm in a master branch. And when I run git status, so it's up to date or to master, there's nothing to commit, or my working tree is clean. And it might be a good idea to bring up Visual Studio Code. That's why I can show the files. I can show everything at once. This makes more sense, I think. Give me a second to get up to speed. All right.
While you're taking that time, so the U does have to do with the tracking. It's short for upstream, and basically it's when it has to do with remote tracking, and it's when you're adding something new to your from your local branch to an upstream branch. It's comparing the changes, and so that's how it like tracks the changes between the two for the like the change log that they have for every repo. So when you first like are making your first commit, you know how we had to do like that what was it? It was like git init. I'm trying to think of what they had us do. Git init u origin master when we like would make a new repo off of one that we initialized in GitHub. That's like just saying like, okay, so all of the changes that we make locally, when you push them up, like the differences between these two, that's what is going to be tracked in the log that's up on our GitHub repository. Does that make sense?
I think so.
Yeah.
Not really, but that's okay.
And you only have to do it like at the very beginning, and then it just kind of automatically does it from then on every time you do a push.
It's a replacement of the command git remote add origin master. But for example,
it's just like a flag to say like, hey, track this too when you're doing this.
okay.
Interesting. All right. So we're going to look at the stage, the repository, and the local files here. So I have, these are some comments that I've added as I'm learning how to work with spreadsheets. There's nothing to commit. The working tree is clean, right? And this, most of this should be just kind of basic and recap for everybody. But here, I'm just going to add new line, right? And I'm going to save this. And then when I run git status, we would expect change is not staged for commit. So this file's been modified. So I would need to, I can add this file, and we're just going to use the add all command. And when I run git status again, you can see that it's ready to be committed. And then I can commit this, add new line. That's a great message. All right, and so now it has actually been committed. When I run git status, you can see it's nothing to commit. The working tree is clean. So that's where I worked my local directory or my working directory first. Then I put it into the index, and then I actually committed it. Does that process make sense to everybody? Is that clear? And how to work with those 3 areas? Very cool.
So you're just not the next stage. You're at the last of the local stuff that's going on, and the next thing would be to push it up to the remote.
Right. So I will not be dealing with remote stuff at all during this code talk.
Okay.
We can do that in a future date if you guys want, but that's adding another level of complexity that
Sure, no problem.
that isn't really useful right now.
Okay.
Right now, it's going to look at how to work locally, and then the remote is going to be as an added thing. That's right. But so if I wanted to
You've gone as
share,
far as you can. You've gone as far as you can on your local at this point.
that's right. If I wanted to share it,
Line
with
of
the world,
everything.
I would push it. That's right. Pushing it would be the next stage if I wanted to get it into a remote repository. That's right. Okay. So those are the 3 areas. Now we look at commits, branches, and head. And if we bring this back up, when I first got started again. So what we have going on with a commit is actually, it's a Git object. It's a commit object, and it has state, it has information, it has data that can be accessed. And we can look at our Git objects, and instead of doing this to Visual Studio Code, I'll move this right here. We can look at our commits with a Git log. So this is a log of all the commits that I've performed in this project so far, right? It has a hash, it has an author, it has a date, it has my comment that I've made, all that data. Now, I personally hate the Git log. I think it looks stupid. It's terrible. It's not really helpful. So I did a little bit of researching, and I found out that you can customize your Git log any way you want, which is pretty neat. And I found a really neat one that I like to use. It's got a better Git log, and we're just going to skip over. This command here is the one that we'll be using. And I've created an alias for that, which I can show you guys how to do that if you like. So I can just run git lg, and it will show my log like this. Now I like this log a lot better. It shows my hash in just a few, like 6 digits instead of the whole long giant thing. I don't need more than 6. It shows me what branch I'm on, it says what the comment was, when it happened, in relation to right now. So this was 3 minutes ago versus 3 days ago, and it shows who did it. We can add any details we want here, but this is useful for me to kind of look through my history and see what's going on in this project. And all the resources I share today, again, I'll make sure that's all sent and shared in our code talk after this is all done. But this was super helpful for me to be able to look at what's going on here. So every one of these lines is a commit object. Now here we have head. Head is it's kind of a complicated concept, but it's a pointer or a reference that addresses what commit object we're currently working with. Head will almost always be pointing to or referencing a branch. And a branch is a history of commits, and the branch name itself will always be referencing the latest commit in its history. Okay? So when I say git checkout master, what I'm doing is I'm going to be changing my head like a dial, like on a radio, right? When you change the radio station, you hear something different. So I'm going to be changing the head to the same commit that master is currently pointing to, which is this one right here. This is the latest commit object inside of the master branch. So I'm going to check that out. Head is now, I'm already on there, but that's fine. So now head is now currently pointed to the same as master. And I know that can be complicated. So visualizing this, I think, is going to be the best way. And if you guys also, if you're not working with, if you ever need to really learn about Git branching or how Git works, I find that the Learn Git Branching website is really just phenomenal. But they have a cool little sandbox you can use on top of their tutorial. This is a really great website. So what we're going to do here is we're going to visualize. So here we have commit 0 and commit 1. Master is currently pointing to commit 1. So if we were to check out master, we'd be looking at whatever is in commit 1. And we're just going to create a little commit here. New commit. Oops, I used the wrong. Here we go. So now we made a new commit. So master moves and is now pointing to the last commit in the tree. Does that make sense? Every time we add a new commit, the branch will always point to the latest one, another one. So now master moves again. So now we're on commit 3.
So where does head come in this part?
Right. So head is right now pointing to master. This is our active branch. You can see that the asterisk is here. So head is pointing to master, and master is pointing to C3. So we'll work with head. Let's make a new branch. We're going to call it new branch. And we're going to, so now you can see that master and new branch are both pointing to the same commit. They're the same right now. But let's check out master, or let's check out new branch. And now I'm going to make another commit. And I should really be using better ones. So let's just say that we're going to add a blue button to a web page, right? So this code has a blue button. So master is still back here at C3. New branch is on C4. Git. So if I check out master, now the head is back here at master again, which means that that's the commit I'm working with right now. Head is always pointing to the commit that is currently active and engaged. And so when you check out different branches, it switches to that branch. And the branch always references the latest commit in its history. Does that make sense? It may not be, you may not be clear why that's relevant, but does that
Makes sense.
okay, cool.
And what's really cool is if you have your code editor up, you can see that the code changes.
That's right. That's right. And so what we want to do now is let's go back to here. So we've kind of referenced these and how they relate to each other. The last really major concept that's important is commit practices, best commit or good commit practices, right? Because when you are working with history, what you're really working with is your git log. And if my history here is just like fix bug, add button, do thing, like if it's really bad, I won't know what in my history is relevant to right now. So if I need to undo something, or if there's a bug somewhere and I want to figure out where my bug came in, if my comments are terrible, I'm never going to be able to go back in time and figure out what happened, and I won't know what to go back to. So it's really important that you commit when you need to, and that your messages are useful to whoever's going to work on your project, especially if it's going to be you in the future. Like nothing's worse than trying to work on code that you don't understand that you wrote, right? So.
And your messages are in the present tense. I was told that I was doing it in the past tense, like filled out gem spec to-dos. And
right.
An instructor told me that it's best practices to do in the present tense.
Huh. Didn't know that.
Well, so I guess so this is Chris Beams. I don't know anything about this guy
I
either.
just pulled up that same page when
Right.
you said that.
So this is the canonical how to write a git message, or git message. That's a great word. A git commit message. This is really, really good. And this will be included with the spreadsheet or the outline I sent you guys. This is the go-to reference. And I like this here, right? So as a project drags on, my git commit messages are less and less informative. So at first, created main loop and timing control, enabled, that's past tense. These are both past tense, which is bad, like Sharon pointed out. Enabled config, miscellaneous bug fixes, code additions, and like, what is that? That's worthless. More code, here have code, and then right, my hands are typing words. So this is a person who's within, 14 hours has made a handful of commits and branched around, and it can become burdensome to make good comments, but it's super valuable. Because if you're working this project, you would not want to have to go back in time and figure out what was going on. So this is really, really good. And he even shows how to customize your Git log to show something a little bit more useful. You can also search your Git log if you have it useful as well, which is really good. So these are the main 7 things that we want to do. We want to separate the subject from the body. So you don't want to have all the details in your message. You want to limit the subject to 50 lines. If 50 lines is plenty, if you need to have more information typed in, more details, you can put those somewhere else. But when you're looking at this, these are just bullet points of my project's history, right? This is the story of my project, bullet pointed. And if I needed to have more details, I can do that later. I can do that as a deeper message, not in the main message. Capitalizing the subject line is good. I don't think I do that. We don't end the subject line with a period. We don't need punctuation in there. We use the imperative mood, which is most easily thought of as a present tense, but it's the imperative mood. Body at 72 characters, that's just a general idea. And then use the body to explain what and why, not how. So we don't want to go through and explain how we accomplished something, just what we did and why we did it. Because when you go back through and look at your code, if you're looking at your messages, you want to know what you did and why you did it, and you can figure everything else out from there. Those are the most useful things, and you guys can read through this. Yeah.
Can I jump in real quick?
You can jump wherever you like.
For the imperative mood, was it imperative mood? I'm a grammar nerd. I studied Spanish, and the best way to explain it, the way I've heard it explained by other people in Flatiron, is write it as if the person who
like you're given a command. You're telling somebody what to do, right?
Well, write it as if you're sending this code in and someone's gonna merge it, and they read like, if I merge this code into my project, it will, and then that's when you start your commit message. It will add comment. It will remove the end. It will create spreadsheets.
Right.
So then you know you're doing it right.
Sure. Telling them what is going to do, or I like his example as if given a command. So clean your room, close the door, take out the trash, add thing, change thing, right? Revert thing. So I like, it makes sense. It's really, it's really useful. And again, like you said, it tells them what is happening with that commit, what it's doing, what it does. So in addition to having good commit messages, it's also really important to know when to commit, how often to commit. And a basic rule of thumb is you can't commit too much, although I probably did in this project a little bit. I don't know. It's good to commit often. And it's really good, even for us now working on our own, it's good idea to always do a pull before you do a push. I would recommend whenever you think you want to do a push, that you just run a git pull first and make that your habit. And the reason why is if the code, so I guess we are going to talk about remotes a little bit here. If the code in your remote, and let's look at this. If the commode here, if the code here is different from the code here, and when I push it, we're going to have to merge that code, right? And so we're going to have to merge it up here. Now, that merge, the push will happen before the merge does. And so we'd have to merge it after the push. So the changes will be up there. And if I push code up here and you decide you're going to do a pull, now you're pulling the unmerged code. So it's going to have the old code and the new code. It's going to have the equal signs. Has everybody seen code that needs to be merged?
Yeah, and I can never tell which one was which.
Right. It has those less than signs and the greater than signs and the equal symbols, right?
Mm-hmm.
So if we push, all that's going to be on the remote repository for everybody to look at. You're going to be embarrassed because it's embarrassing. But worse than that is if somebody else pulls that code down and is different from their code, now they're going to have to merge that with their changes, and it's going to be a nightmare and a mess. It's just bad. So you always want to do a pull, even if you're the only person in the project, just to make it your workflow, your best practice. You pull it. If there's any changes, you merge them here locally, and then you push up the clean. There's not going to be any problems code after that. Does that make sense? So git commit often, git pull, and then git push. And that's a good way to do it. And like we said, pull is the same as a fetch and a merge all wrapped up into one. Now, I also want to point out that when we're working with our history, I previously did the git add all, right? But we don't have to always do that. This is sometimes not a good choice. So I only have 2 files here. Let's just do something here, right? So let's say that I am going to all of a sudden, I'm going to make some change here. I'm going to save that. And then in my spreadsheet, I'm going to make a spreadsheet thing, right? So now when I do my git, oops, that was the wrong button. When I do git status, that's not how you spell status. Git status, there are 2 files that have been changed, right? I could have added and committed each one of those changes individually, assuming these are both different features. But now they're both here. I can add each one individually. And in order to have a good commit history and a good commit message for each one of these, I really want to add each one on its own and not both. Git add p lets you stage changes individually. So I've never worked with the -p. What I've done is just put in the individual file itself, right? So now when I run a git status, so I've never used git -p, I'll want to look at that. So now I have this one that's ready to be committed. So if I run a commit right now, I'm only going to commit the changes to my spreadsheet. And so I can make a message where I make new spreadsheet thing. So now I've only done that one. And if I run git status, this other unchanged file is still here I can add it separately. So when you have changes in multiple files and they're not related, you should really add and commit those individually. But if you have changes of multiple files, but they're all related to the same thing, you need to add all those at the same time. So your message it makes sense across that, right? If they're all related to adding the blue button. So you change some CSS code, you change your HTML file, maybe JavaScript, whatever, but they're all related to the same feature, you should add all those at the same time and commit all that at the same time. If their changes are not directly related, you want to add and commit each one individually, like interactively. Yeah.
Hey guys, so at this point, where it says the second paragraph says use git checkout, to discard changes in the working tree for the file, the Learn Ruby spreadsheet. So where we are in time and space right now is that, did this file at one point get staged? So has it been staged, but then we made new changes on our local? Is that where we're at?
It is not.
Checkout? No?
Let's look at this. So right now we are in this. We are here. So this is the file, right? Version RB. So it's this, but my index or my stage and my head are the same. They're the same, but my working directory is different. So it's saying this file is different from what's in the stage and what's currently in my repository. If I add the file, it will become staged. But so let's look at the version and I'll show you what happens. So let's run the command it shows, right? Git checkout, and then it's not going to let me just.
I think you need a space between the dashes and lib.
I think you're right. Learn Ruby spreadsheets. So you see it deleted my code?
Yeah.
So that's what happened. When I ran git checkout, I discarded the changes in my working directory. I deleted. It's best to think of your working directory as a sandbox for your Git repository. And so it's saying, hey, you modified this. If you want to actually save this, you need to add it to your stage and then you can commit it. But if you don't want to keep those changes, go ahead and just run this command and we'll discard the changes in the working directory. Right?
Cool. Yep.
So that's really useful. All right. That's, where am I? Here I am. So those are the basic Git practices. So now we're going to be looking at these commands. And I'm going to show you quick as I can. First, are there any more questions? Sharon's really, really good at jumping in and asking questions. I appreciate that. Does anybody else have any questions? Or any comments?
I mean, I do, but it's a problem that I've actually posted on Slack before, but I guess we can wait.
Okay, sure.
Yeah.
All right, so stash. If you ever try to check out a branch and Git complains that there are changes that are not yet committed, it can tell you that you might want to just go ahead and stash them. So let's just do an example of this. And I'm going to use comments again. So 2 + 2 = 4. So that's pretty good, right? So I'm going to save this. And if I run git status, we'll see that there's a modified file. I can add it or I can discard it. But now I'm going to make a new branch, git branch. For, I'm just going to call it blue button. I don't know, that comes to my head all the time. Blue button. So now I'm going to check out the blue button branch. But it says, so this M means this is modified. I switched to blue button. It actually didn't do what I thought it was going to do. That's kind of weird. Normally it complains. Because, actually, I don't know what just happened here. I have no idea what I just did. That's really crazy. Normally it would complain that I have some files that were changed. That's cool. So as you can see, I'm not a master of Git. I know some things, but there's some things I don't know. So we're going to disregard that for now. What stash does is it's kind of like it's a work in progress, or it's like a branch. It's like another branch in your code where you can stash your changes, and you can always reapply your changes later if you want. So what I'm going to do, what I use git stash for is if I'm trying to figure something out in my code and I'm not sure if this is going to be the solution I want to go with, and by the time I get to the end of what I'm doing, I don't really like it, or I want to try something different, I will run git stash, and it is the same thing as git checkout file, right? But it will do that for all of your changes. So you can see it deleted the code in my working directory. Does that make sense?
Yes and no.
So let's do
So
the
the
exact.
comparison would be, so for example, if I were in a situation where I wanted to make some changes, I wasn't really quite sure, why would I not create a new branch?
Sure, you could do that, and that's a good practice. And I'm not telling you that the way I'm using git stash is the way it's meant to be used. It's just the way that I use it. It's just a small thing where I'm going to try something out, and I'm not really sure about it, or I decide I don't like it. I'll just run git stash and it deletes it.
So the word is good. I think stash. It's like you're just going to tuck this away for now. Let's say
Right.
that you know that someone has done some major changes and you want to pull them down, and you're not really sure if you're married to what you've been doing. You're just in a spot that I got to do something. You stash it.
That's right. Is it one?
I think that's how I've used it when I've been in trouble.
Okay, sure.
But then how do you bring it back?
So you run git stash list, and it shows you all the stashes you've made. And then you can use, it's called apply. I forgot I stashed this. That's cool. You can use a command called apply to bring that back. And you can apply it to any branch. So changes you make in one branch, you can stash them, go to another branch, and you can apply them there. I've never done that. I've just read about it. So I like to use stash just to kind of just to change a working directory back to the way it was. If I'm not going to commit my changes, rather than going back through each file and deleting all the code that I don't like that I just made, I'm like, I'm not going to commit you. I don't like what you're doing. I'm just going to stash all those changes and start back the way I was at my last commit.
So it would be git stash apply.
I guess we can look at that real quick. I've never done it. So git stash apply. It's apply and pop. That's right.
Yeah, I've used pop before.
Right. So that will bring, I assume it's the same thing. I've never actually done this. We'll do this live. Doing things live is never good.
But what we're talking about right now, I completely was in unknown territory. I was just told to do it, and I was just praying for the best.
Okay. So it's like git stash apply does something. Let's see what it does. Stash apply. I assume I have to specify something. Make new spreadsheet thing. Oh, I should be here. Yeah, here it is, right? So when I ran git stash, nope, I don't know what's going on.
I don't want to take you off your course. I'm sorry.
Well, I think you've already done it. So I think I just need to specify the git stash apply. Do I need to specify the stash at, what is it, 1 or 0? No, that's not it. Okay, I'll look at that later. But somehow you can do that. And then you know how to use pop. That just brings the last one in. Apply leaves the stash around. Is index. Okay. All right, we got 14 minutes. I think I can do this. All right, amend. This is a really cool command. I like this one a lot because I sometimes have typos in my commit messages. So amend, this right here by itself will put you into a situation where you can change the commit message. So your last commit message. So if I run git commit m, so I have, let's just look at my log one more time because I've changed some things. So this is my log, make new spreadsheet things, the last one, right? So I can run git commit mend, then I'm just going to change the message here. If there were a typo, that's a good time to do that, right? I'm not good at this. Let's do this. Git commit m change font. Okay, get LG. Oh, I can't commit anything, can I? I'm getting ahead of myself. So font size equals.
Can you only amend the last commit, or you could amend any of them?
Amend only works the last one. So let's add commit m change font size. There we go. So now if I run git log, I change font size. I should have made a typo in there. That would have been better. So commit, amend, m, make font size 12. Oops, mn needs 2. The flag. So now if I run my git log again, you can see make font size 12. And that's the only thing that changes now, is I just changed the message. You can update the message. Rather than, so if you have a typo in your message, you can run the amend command and it will let you change that. But if you have any staged files, you can also add those to your previous commit. So let me show you what that looks like. So I'm going to make a new file inside of here. We're going to call this index.html. So this is HTML. But that's cool. So I have this, and if I run git status, we'll see that's not staged. So I'm going to go ahead and stage that, and then I'm going to run git commit amend. And I'm just going to let it bring me into my editor this way. Oops, what did I do wrong?
Put 2 M's in amend. Or something.
No, I don't think so. Amend is 1 M, and this.
There we go.
I'm looking at something.
So what I'm doing right now is I'm in this editor. I'm actually going to add, so I have this previous commit that did not include the index. But let's say that I meant to include this file in that commit message, but for some reason I didn't. Who knows why? I'm going to amend that previous commit. I'm going to add this new file to that old commit that just happened. Does that make sense? So make font size 12. Now this is really a bad way to do it, and add index.html. So now this index.html is included with the previous commit message, the commit that I just made, that commit object. Does that make sense?
I missed it. When did you actually commit the file itself? Not trying to. Wait. So wait a minute.
Go ahead.
I don't know what you just did.
Sure. So what I did is I had a commit I created inside of my spreadsheet is I made font size equals 12, right? And then I made a commit with that change.
Mm-hmm.
And then after that, I created index.html. I staged this up here.
You staged what?
The index.html,
okay.
right? I staged everything, but this was the only change. Then I ran git commit amend. And because this file was staged, when I ran this command, it now amended the previous commit and by adding everything that was staged to it.
So your last actions, basically.
Your very last commit. You can change anything about your most recent commit. You can add new files to it. You can change the commit message. I don't think you can delete files from it though, but you can amend your last commit with this amend command.
That's very handy.
It is. So again, amend just by itself, this is how if there's nothing staged, this that will let you update the message. And that's all it'll do. If you have files that are staged for a commit and you run amend, it'll add those files to your previous one as well.
So amend only works for the previous commit. It will not. You can't cherry pick a commit, right?
That's right. So if you want to do that, what you need to do, Ian, is called rebase. We're not going to work with rebase today.
Okay.
So get rebase is like the amend, but you can do it with your entire history. You can amend any commit in your entire history of commits. Change messages, you can move commits around, you can add new files to them, you can do anything you want. Rebase is powerful and dangerous.
Yeah, that's what I wanted to touch base with you if you have time afterwards.
So now the last two things we need to talk about is revert and reset. Now this might be the main reason why you guys are here today, to kind of learn about this stage, is revert and reset. Revert works with, what revert does is it does the inverse of your last commit. So if your last commit, you added a blue button, revert will make another commit where that blue button is removed. And it's important to remember that revert adds a new commit with the changed code. It doesn't delete any of your commits. Reset will actually delete commits out of your history so that they're gone. And we'll look at those. So let's go back into Visual Studio Code.
Why would you choose to revert over reset?
So let's say I have code pushed up into GitHub and I was bad and I added a new bug, right? I wanted to change the font size to 12, but instead I linked, like my entire website is now just one big GIF of a cat playing with yarn. I don't know how I did that, but that sucks. So I can just revert that so that maybe I don't have the font size equal to 12 anymore, but I also don't have a giant cat playing with yarn. So I reverted it, and now anybody can look at my Git history and see, oh, he reverted that change. They can see the history there. So if we're collaborating, you can look at the code that created the bug, and you can look at how that was fixed. So when you're looking through your history, you can see what happened and why you're not out in the blue.
Ah, okay. So it's basically it's to clean up the Git history. It's mainly used for bug fixing then, Git reverting.
I can't.
Well, you could also like use it to track, because especially if you're trying to implement different things, like let's say you're designing the UI and UX part of your app, and you're trying different stuff, and for whatever reason you don't like what you're trying and you keep reverting, you have a record of what you've tried already.
Right.
Oh, no. Okay.
And so does your team who's working
here's
and your
where,
boss.
right. Everybody sees what you've done.
Yeah.
It's not just gone forever.
Well, I mean, I would assume that you would want to, cover your tracks whenever you create a bug. Like, no, I didn't do the bug. That's not there.
It really depends. If all you did was create a bug, I can see that. But if you have other code in there too that maybe was useful, you can look at the code that created the bug. You can see, okay, this is what I was trying to do. Here's how I tried to do it and failed. Let me try a different way now. If you just delete that altogether, you don't have that history anymore. Right. And history is valuable both in like the real world and in your code project.
So if you wanted to recreate something you did, let's say you made 3 changes.
Yep.
And it's like, you know what, you said to try it red, you said to try it blue, you said to try it yellow. I tried all of them, and we don't like any of them. So we're going to revert just to show that we did what you suggested. Is that kind of what you're saying?
Sure. If you have a project manager who wants to at least see that you tried it, you could do that.
Okay. And that happens. And so then, how would you say? So, do you do anything that would make those changes actually get called up again, or is it just are you just affecting the history or the messaging of what happened, or is it still somewhere in its memory where you can pull it back up?
Right. So let's look at that. What I've just done here, this is all of my history, right? My Git log. I revert the head, and the head's what we typically work with when we do a revert or a reset. So the head, which is currently pointed to master branch, reverted, which means it went back to the previous commit and was like, hey, this is the changes that were made. Let's undo that. And the way that I undid it is that there are 2 files that were changed. There were 2 things that were deleted.
Mm-hmm.
And when I run my log again, you can see there's a new message called revert. I just leave the default. I like the default. So here, I make font size 12 and add index to HTML. Here, I revert make font size 12 and add index to HTML. Right? So this is what I did. This is how it was reverted. And so you can look inside of I don't have that index to HTML anymore. And I don't have the line that said make font size 12. Those are deleted out of my local working history. They're gone. I can move my head back in time, right? I can reset the head, which we'll talk about, but it actually, it affects your actual code when you revert your head. It undoes what you did last. But I still have all of this history, and so I can just go back in time, right? So, and let's do this inside of Visual Studio Code so you can see the changes happen in real time. So now I'm going to and I'm going to reset, and I'm going to use the hard, and we'll talk about that, head, and I'm going to use the parent selector rather than targeting a commit directly. So I'm going to reset the head back 1. So you can see the index came back and my font size came back. And now if I run my git log, I don't have the revert commit. It's gone. Like it never happened. Like I never reverted anything at all. It's just gone because I reset. Now, if I do it again, let's git revert hard head. So now the make font size 12 index to HTML will no longer be there. So now I made a spreadsheet thing. Let's reset the head again, and let's do it again. Right? Every time I do it, it's actually changing my code. Everything I've done, I'm undoing them one at a time. And you can see head is now at this commit. Head is now at this commit. What it does is it takes the head, it goes to the parent or the previous commit, and so it dials the head into that commit. And because I use the hard flag, everything is the same. If you guys want to hang out, I'm going to explain the 3 modes of reset real quick, or you're free to go. But you can see if I run git log again, this is all I have. And if I keep doing it, I can go all the way back in time to where nothing happened. And you don't have to just select this, right? I can select any one of these commits and go back in time to that point. And everything after that point gets deleted and wiped off my computer. It's just gone. So I'm going to pull this project because I have not pushed it, and I don't want to push it because that seems like it could suck. So now if I do my git log, this is the way it was before our code talk tonight, which is the way I want it. All right. There are 3 modes for a reset. We have hard, we have mixed, and we have soft. And they build on each other. So mixed does everything soft does plus something. Hard does everything mixed does plus something. All right, what soft will do is it moves the head back 1 position, but it leaves your index and your working directory unchanged. Mixed will move the head back and it changes your index. Hard moves the head back 1 and it changes your index and your working files. As you can see, it deleted lines of code, right? I was doing the hard each time. It actually deleted stuff. It changed files on my actual hard drive. So let me just show you. Look at my git log one more time. Add comments for how to iterate spreadsheets. That's these lines of code is what my last commit did. If I do a git reset hard head, I'm gonna use the parent selector for the first parent. You can see it deletes those those lines of code are actually gone. So let me pull these again, and they'll come back. So now if I do a git reset, let's do mixed. Actually, this is the default. You don't need to select that at all. If you don't give it any kind of mode, the default is mixed. So the head went back. My code is still there. And if I want to get status, it'll show me there are modified files that are not staged to be committed. So it's almost like you went back just before you ran your git add and git commit. Does that make sense? So at this point, I could recreate my last commit I'd have to stage my files, and then I'd have to commit them again. I don't remember what my commit message was, but other message. This is another message. Oops, I forgot to do that. So now that's back just the way it was. And I'm going to get reset head parent again. And so if I do a git status, so nothing on my working directory, right? There's 3 places to look at, 3 areas. Nothing on my working directory has changed, but my index and my repository both say, hey, there's changes that we aren't tracking. So let's go ahead and take care of that. Does that make sense? Let's pull this again.
Yes.
Now I'm going to do the soft. Git reset. Oops, not one of the arguments. Soft head parent selector. Enter. And now if I want to get status. So now what happened? This probably wasn't the best change to show that on. So what soft will do is it moves the head back 1 commit, and the working directory and the stage are now in the same state, but the repository shows that there's something different. And maybe let's look at this one more time. So when you do, I think this actually shows it pretty good too. Reset soft. So what happened here, the working directory and the index, these are the same when you do a soft, but your head is different. So this is a change you made, it's staged, and you can commit it if you want, but you don't have to. That is soft. If you do mixed, your working directory is on its own, but the head and the index aren't tracking the changes you've made. And if you do hard, they all 3 are the same, which means it goes back in time and just wipes out whatever changes were made.
Mm-hmm.
Does anybody have any questions about that? Does that make sense?
No, your resources are excellent.
Yeah.
Definitely gotta take a look at them and play around.
Absolutely. It's the soft is really the same thing as doing is a detached head. Is checking out the previous commit, which we don't want to do. So if you've ever had that situation, it's kind of like that. I think that's really all of my notes. I've covered everything I intended to cover, maybe a little more quickly than I thought. My timing, I need to get better at figuring out how long things take. But I'm available. Does anybody have any more questions or comments?
It was great. I liked this a lot. I'd like to do this one again.
Okay.
Maybe go a little bit further. I posted something that is all about what do you do? What happened? What do I do? I messed up. It's called
Right.
Oh Shit Git. And it covered a lot of what you covered.
Cool.
And then some.
Yeah. This is a really good resource.
So what was the sandbox one? What was the link for that?
So if you
Learning
just
branching. Okay.
yeah, if you just go to learngitbranching.js.org, or if you just Google learn git branching, if you can't remember the thing, that's the
Okay.
top link. Learn git branching.
And we'll put all this stuff on the Code Talk Slack channel too.
Okay.
So when you jump into this for the first time, it says want to go straight to a sandbox, you can do this special link right here. And this lets you do that kind of stuff. So what's really neat about this is, so right now if I can do a revert. Oops, sorry, you have to select head. And so it adds a new commit. This is now going to be the same as C1, right? The code will look the same, but you can kind of see things happen. And if I want to undo that, I'm going to do a git. I'm going to use hard. which is the only one that's dangerous. It's really not a good idea to use hard unless you're really, really sure you want to delete your code, because the only way to get that code back is to bring it in from an outside source when you use hard. So I'm going to use head with the parent selector, and you can see it now goes back to here. So where I never did anything at all. Now I'm going to do it again. So it's really helpful.
Hey guys, this session is really great. I recently, used one of Altisan Bitbucket, where they had all the code, the source code, development source code was on the cloud, and it was integrated with Git. So that was very interesting. I shared one link for Altisan in the chat.
Awesome.
Thank you.
Yeah, so I like that. Assume this is what you said, Atlassian. So this.
Yeah. So this has some tutorials. Even I'm looking into it. How to integrate with other source codes. Like this example is with Bitbucket.
Right. So they have an interactive tutorial you can do. It's pretty good. This will also show you. This is also in my notes. It shows you how to format your log output with different ways. So it's pretty helpful.
Thanks, Scott. Appreciate it. You have a great rest of the day.
You too.
Thank you, everyone.
Bye.
Bye.
Bye. All right. Ian, I'm cool to hang out if you want to ask me the question here.
Okay, cool. So I found myself in quite a situation. So basically what was happening was I was developing on a personal project.
Okay.
And I bought in a new machine. And basically when I did a git config username, I changed the name inadvertently so that it was different than what my project name was. So I went ahead and I did a push, and now it's saying if I want to do a pull request. And for the sake of consistency, is there a way to normalize the username across the entire Git history? Or is my question not making sense?
So I believe you can use rebase for that purpose.
Okay.
So here I can see my name.
Right.
Oops. Oh. Let me just stash my unstaged changes. Now it shows me that command when nobody's watching. Whatever. So. All right. Nope. I don't know what that is. What is this? That's weird.
No op, but.
Oh, you're right. That makes more sense than nope.
Nope.
Yeah.
Don't go here.
So use commit, edit the message, stop for amending. No.
Hey, guys, just so you know, you're still recording. I don't know if you want it to be or not.
Oh, did it? Yeah.
Should I not be? I don't know. Maybe.
I don't know. Just
if you're still watching this, you're free not to watch it. I mean, it's your life. Spend it
You're
how.
free to unsee it. You're free to unsee it.
So you know what? I don't know. Let's Google that. So git change. So you want to change author of last commit. Let's look at that.
I guess so, but but I'm the only author, right? So.
Well, you have the wrong name, right?
I just put like, instead of Ian Canino, I put in a initial of my name. And so when I went on to GitHub, it said that I got a new pull request from my new name. And it, I'm assuming it doesn't really matter to me now in my personal project. Hey, I know who it is. But like, if I run into a situation in the future, for whatever strange reason, I'd like to know how I would go about fixing that.
Author.
I already did a git push, so I can't really do a git reset hard or anything like that.
I had a similar thing. Like I was using one of the GitHub user IDs, and then I wanted to use a different email address configuration. But I think it is something different than what Ian is saying.
Well, I mean, I would assume that it's the same at the, well, maybe not. Email would be the identifying.
Right, because right now we are just integrating our the local machine to one GitHub repository, right?
Mm-hmm.
Hey, there we go. Is that what you
Okay.
wanted to do?
What did you say? Git commit, amend, author, some other guy, and then you have. Oh, okay.
Yeah, that seemed to do it. So I just, this is not going to be in our notes. So I will send this to the chat, and anybody can look at this if you want.
Yeah.
So it's like you can just amend the previous commit. And so you should be able to do the same thing with rebase here.
-IB, okay.
Right. And so you can follow this if you want. There's 10 steps. That seems ridiculous, but you know.
Right.
Cool.
And I do have one other question, although I think that will solve my problem. I started mucking about with subtrees. Are you familiar with that?
I was looking into that a little bit myself.
Yeah.
But it didn't really go where I wanted it to go.
Yeah, I'm assuming that what's going to happen with me, because I'm working on a project and I want to do a separate Git for the back end and the front end.
Okay.
Have the project Git that would be the subtree, the back
Right.
end. Yeah, I don't know if that was such a good idea. From your experience, you think that maybe I was overcomplicating matters?
No, as long as you are fine with just working with two different Git repositories.
I think that problem with going out with that when I do a Git add, you'd have to be really careful to make sure that you did Git subtree add as opposed to Git add, because you did a Git add, then it would go into the parent directory, the parent repository, but it would not necessarily be reflected individually in the subtree, and I completely screwed up the history.
I see.
So when that happened, I just basically ended up doing the project all over together. And I was just wondering if that was even a recommended manner to divide the Git history, I guess.
Yeah. That sounds complicated.
Yeah, I know. I just thought that, the back end, I was using one code base, and the front end, I was using a different code base. So it makes sense to separate the two.
There's probably a best practice for that we're just not really familiar with. Practices.
It didn't seem to make sense to me for me to have it all in one Git, especially if the back end could be used for something else.
So,
like the back end could be used for a different front end if you wanted to, right? Like it was a CRUD server, it was an API server, and
normally you keep it all together.
I'm sorry?
Well, what I've learned is that you keep it all together.
But then what happened if you wanted to extrapolate that back end and change the front end?
So it really depends, right? So I think that if you're going to keep them separate, you need to keep the code separate too.
So you would never say the repository was subtree. You would just have it completely separate anyway.
Yes. So if you want to create a backend that can work with any front end, don't mix your code up. Make it its own backend that anybody could then attach a front end to. And if you want a front end that can work with any backend, keep it separate. So anybody, keep the mindset, I'm going to make it so anybody could fork this project and attach any backend to it and it'll work. So if your backend code's mixed into that, I can't use your code now. And so that's not going to be good. So I think, in my opinion, if you're going to be doing separate trees, separate repositories, make them separate projects that can work together.
I get the problem with that they're separate projects. I mean, you have to have separate directories. Yeah, okay, fair enough.
Right.
Yeah, okay.
And that will give you the flexibility then to use your own code however you want going forward. And you won't have to try to de-interlace your project to like, hey, I liked why I did this back end, but now I want to use a different front end. Oh crap, let me go and delete all this other front end code that's built in.
Right.
You can fork your own project, clone it into a new repository, and attach a front end however you want.
So I overcomplicated matters by using subtrees then. This is one of those use cases where subtrees is just like I'm beating a dead horse on it.
That is my opinion. Yeah.
Okay, no, fair enough. I know there's like, 1,000 million different ways to do things. Just trying to jump ahead of the game and trying to not make the mistakes.
But I mean, I think your experience with using the subtrees in that way, you learned probably a lot of things that a lot of us haven't had a chance to mess with yet. So I think it was probably a valuable exercise anyway. That was probably good for you to do. But I think you just learned one more way not to set up a project, I think. Right? So I think that's good.
All right, cool. Awesome. Thank you so much for, providing this lesson. It was awesome.
Yeah, I had a good time.
Yeah, thanks. And I still think of that as the Borg, by the way, the little light coming out of the
yeah.
But it's cool. It's cool.
Yeah.
Yeah.
It is cool.
Thanks so much.
Yeah, take it easy, Ian.
All right, you too.
Does anybody else have anything, or we can be done?
Yeah, I'm done. I'm just getting some notes together to send over to you.
Cool. All right, I'm going to hit the stop button.
Yeah, thank you.
And I need to hit the stop recording.